Morning, everybody. I'm going to fight with Google Docs here for a second. All right, cool. So like Bill said, I'm Adam Cofer, computational engineer, lead developer, and sysadmin. We're a very small company. We have developed something called Time Zero Map, and we're going to be launching it in the next month or so, actually getting some actual paying customers in. That would be awesome. SimCenter Enterprises is the company I work for. This is a graphic that represents the initial idea of SimCenter Enterprises, which was to take the SimCenter at UTC and all of the awesome things that they can do and make products out of that and get it to private enterprise. We're funded by philanthropic foundations, which is awesome. And we're trying to keep a partnership going between the different colleges and take some of that really awesome IP and get it out there. Computational engineering is what the SimCenter does. That's what you get a degree in if you go there. And it's solving engineering problems with computers. There are different engineering problems that you can use, different engineering problems you can use computers to solve: mechanical, electrical, aerospace engineering. The aerospace engineering, that's mostly fluid dynamics. So that's water, air, flow problems, and there's a lot of math involved. There's really, really horrible math involved. I still have nightmares about this, but thankfully I don't have to deal with it anymore. So we are a nonprofit startup, so we actually don't have access to a supercomputer to run things on constantly. The only supercomputer we've got in Chattanooga, as far as I know, is the SimCenter at UTC, and it's being used for research right now. So we're going to keep it really simple. I have a picture of the Raspberry Pi because Raspberry Pis are cool. So we were casting around for what we could do with engineering expertise, but not having a supercomputer, problems that we could solve. And Dr. McDonald and some other people talked about it and came up with plume dispersion modeling, which is an older discipline. It's super, super simplified fluid dynamics. You take all of those equations basically and take a whole lot of terms out of them. And you can simulate the release of gases into the atmosphere. It is quasi three-dimensional. The simplifications kind of occur crosswind and upwind and all that kind of stuff. And there's lots of literature to support it. So it's a really well-researched field, and there's a lot of code out there that has been tried and tested and is available for free to download, and it could potentially be very, very helpful, and you'll see why here in just a second. These are the kind of results that you get from a plume dispersion model. Basically, you model a chemical release at a point source, and then it will tell you how far downwind that chemical is going to go and how fast it's going to disperse into the atmosphere. And you get, if you dump the output and plot it on a command line, you get something like this, which you see that spike at the point source of the concentration of the chemical that's been released. And these little contour lines down at the bottom tell you different levels of impact if somebody were to be standing in that area. So the biggest contour is purple, and that's where you'd be really irritated. And then as you go further in, it gets more and more dangerous to be standing next to that source when a chemical is released. But this is the state of the art in plume dispersion modeling currently. This is what's out there. This is free software by the EPA and NOAA, and it's intended for first responders to, when they hear of an accident, to enter everything about the accident and get that model so that they know what areas they might need to evacuate or what areas they need to not go into. We've talked to several of them, and they call their current method the cop-o-matic detector. Basically, they send the police in, and when the police fall down or start throwing up, they back off, right? So the tool that they have now, instead of doing that, is to, okay, pick a chemical. Now, imagine this is a tanker that's overturned, and there's a dangerous chemical that's been released. Enter the wind speed. the direction the wind speed's from, what the ground roughness is, what the current cloud cover is, what the current air temperature is, what the atmospheric stability class currently is, whether there's an inversion layer present, how humid is it. Okay, now you get to the actual chemical spill. So what units do you want it in? Do you want cubic meters? Did someone call you up and say, I had 300 cubic meters of chlorine spill? Probably not. So you have an instantaneous source, and you can just enter this many pounds or cubic meters or whatever you want. And this is only one type of chemical release that you can model with this. This is what looks like your summary output. And then you also pick what thresholds you want for that chemical. Is it 20 parts per million, 2 parts per million, and 0.5 parts per million? And after all of that input, you get this output. And I don't think that's terribly helpful. So that is the state-of-the-art in plume dispersion modeling. That is what everybody uses if they're a hazmat first responder. So we thought we could do a little better than that. And we have taken Google Maps and some other web services and some code from the EPA that runs this exact same proven sort of dispersion model and made a modern web application. We've tried to make it as easy as possible. You can just tap on the map and it will drop a pin and it will geocode the address, pull in everything about it, and then you just pick the chemical and how much there is. Actually, a couple of these fields are going away. I've taken a couple of these out that we're going to calculate automatically. And so all you have to do is pick the chemical and how much there is. Just tap the map and boom, you're done. And the thing about this is you can share it with people. So instead of that graphic where you take a screenshot and you email it to everybody, and maybe they check their email, this, everybody can log into the same website, everybody can, in your organization can see the results. And that's really powerful for first responders because it gives them what they call a common operational picture, situational awareness. This is lingo that I've picked up talking to firefighters in the past few months, right? And on the development side, we've tried to keep it as simple as we can. So a lot of you probably know exactly what this is. This is a Jenga model. This is the full Jenga model for the application. Everything lives in a scalable database with a Jenga web application that's pretty standard. And using that framework, we can build a web application that is very simple, and yet we can make it responsive, we can make it intuitive. It works a lot better. We've exposed all of this stuff, all of the results that we have through a JSON API. So we are ready when the time comes to make a mobile app, and it will just slurp up the same JSON and do fun things with it. So the important thing is that everybody can look at this same map, pan around it, zoom into the map, zoom out of the map, and see the areas where things might be super dangerous. So in this case, 28 parts per million of chlorine is really, really, really bad. And you're going to see what streets you need to close off, and you might see what buildings you need to call people and tell them to shut all the windows and doors and shelter in place. So we are in the business of providing decision support, simulation and models that give actionable intelligence to responders that can really help them make really important decisions. So let's do a live demo. Let's see how this looks at 640 by 480 or whatever this is. All right, that part worked, that's good. So, where are we? Like here-ish, right? Drop a map. Let's do ammonia, 30 minutes. Let's do a huge spill and see what happens. Oh, yeah, that was too big a spill. You get a big red ring. But if you have a smaller spill, like this one is chlorine, you actually get a defined area, threat zone. So that gives you a lot more information. You still get wind direction, so you know which way is downwind, and you can act on that. See if I revise that down. Maybe a little less ammonia. Oh, and the other thing that's really important is if you make a site active. So we've been talking to first responders, and man, we really need to clean up that top bar. We've been talking to first responders, and the most important thing is they can see the current situation on the ground. So if you can mark one of these as an active spill. Yeah, let me back up actually. The point of this is that you enter all of these sites beforehand, right? You can actually go to a big map that you might already have of where there might be toxic chemicals stored, like Archer Daniels Midland has a bunch of ammonia and chlorine on hand, that kind of thing. And you can say, okay, I know that there might be a chlorine spill, here's my worst case. And you can enter that in beforehand and just sit there and watch it all the time. And if something happens, you glance up at your monitor that you have running this application and start making your phone calls. And you can designate it as active and tell everybody, okay, you need to go to this site and you need to see which one is active. And that's the one that we're going to be responding to. So that's the live demo. It's really simple right now. You get just a little bit of information when you click this. We want to keep improving this. We want to make it more responsive. We want to give them just the information that we need. So we're trying to do it as an agile development thing. So we're going to do a release every 2 weeks. We're going to keep incorporating feedback and doing sprints and making sure it gets better and better. And I'm really looking forward to that. That's going to be the fun part. So that's it. Tried to keep it as short as I could. And just wanted to thank the foundations who've given us some money. I want to plug Duncan Ingram, some really good friends of mine, local development company. They're out in Nixon. They've done a whole lot of the heavy lifting for the JavaScript and the UI end of things and the systems architecture. And we're using Google Maps. We're hosting it in Rackspace. We're pulling weather APIs from Weather Underground and Forecast.io. So it's been really cool to take some of this older plume dispersion modeling code and kind of pull it into the modern era and make it work on the web. So that's it.
Any questions?
Yeah.
What kind of computers are you running the simulations on right now?
So the simulation is not computationally intensive at all.
Okay.
So it's actually just running on the web server.
Wow.
Yeah. It just takes like a second or two to run. And it's running over and over and over. Yeah. There is still some math involved, but it's not like partial differential equations. It's seriously just like, it's mostly just algebra. Like they reduced everything to algebra to get it to run really, really fast. Because it was written in 1994. Yeah. Yeah.
The city's talked about doing open stuff. Are you?
Yeah. We're not working with them. We would love to work with, is it Open Chattanooga?
Yeah, they've asked you before about whatever that is. What was it where they have
Chattanooga Forward or?
Yeah. So, like I've seen the Google.
Submit an idea and then they review it and then you go before them and then they try to.
Yeah, we are talking to my cousin's a lieutenant in the police force, and I got him to bring some people in. We're talking to the police force and the fire department. We're going to meet with them again in a couple of weeks, but we haven't talked to like the library folks and Open Data Chattanooga guys. That would be really cool. I know that Google has its points of interest service as part of its API, but it would be awesome if we had like real data from a particular city that we could pull in and show off. Like, okay, so if you get your city to provide data access in an API, we can pull it in. This is what we can do with it. That would be cool.
What do they currently pay for the software that they're using?
So the old software that I showed you is free. That doesn't count training time though. So we're trying to, the way we're positioning this in the market is you don't have to send people for training. This is going to be way more intuitive. And then there is going to be a license fee, but the whole city is going to pay the license fee, and then they can give anybody they want an account to use it. I would prefer to open source it, but I'm an idealist like that. Yeah, they say they've paid my salary long enough, they want to get some money back from it, so I understand that.
So how do you, nice job, how do you plan to get it out? How do you plan to market, how do you plan to sell it?
We've gone to a couple of hazmat responder conferences and gotten a pretty good mailing list of people who are actual hazmat technicians and planning coordinators for their cities. And we've published some stuff in some trade publications. If you've got some other ideas for how to market it, we'd love to hear from you. We've already got Google Analytics in place, so we're tracking search results and where people come from, that kind of thing. Other
Do you
ideas.
have a sense on what your license fee is going to be cost-wise?
Yeah, for a city, right now we're talking about, we're still taking feedback from people, but right now we're talking about for like a metropolitan area or a county that has 50,000 people, and we're just kind of estimating what load it's going to put on our servers. We charge them somewhere around like $3,000 to $4,000 a year for a subscription to the web application, and that's for their entire area. That's everybody they want to give an account to. And we've gotten some pretty good feedback on that. People have said, yeah, that fits in our budget really well.
So who's doing sales?
Tim and Jay Davis with the Novanet group in Atlanta, he's come up and he's going to start doing sales, and he's going to hire some people. Yeah, they've been doing demos every couple of days actually to different people that we've run into at conferences.
So you're a nonprofit, is that right?
Yeah.
Good
Yeah.
cause.
Because we were set up as a research commercialization nonprofit entity with donations
Okay, so this comes back to the
from
center.
foundations.
Okay, okay.
Yeah.
So project out, what should you be doing revenue-wise in 3 years? Have you done any?
Yeah, my boss has done the projections and he's got the spreadsheet, but he said if we get somewhere around 100 and 110 subscribers, 110 licenses, we're at the break-even point for the first year. Because our burn rate's really low because there's just 5 people in the company. So,
110 at $3,000, $3,000.
yeah. Yeah.
That is over a couple of years, that's nothing. Like if that's like 55,
Yeah,
60 people, you know.
that's in a year, yeah.
So how long have y'all been working on this specific product? Because I know when I was with Enterprises, we were doing something fairly different.
Still doing different stuff. Yeah, we started this like a month after you left, so it's been like 9 months, something like that. Yeah, it's gestated for 9 months, so yeah.
That's about to go live.
Not ready to give birth.
I hope it's not too painful.